Hey guys, how are you doing? Uh, what is the energy after the break? Are you okay? This content won't be so hard, I think. I will try to make some jokes because performance sometimes is boring. So I will show how to use or how to make something fun using JavaScript and improving a little bit your code. So I'm Eric. I came from the other side of the world. I came from Brazil. And I will try to share something, and I really want you to use these tips. So let's go. So first of all, who is the backenders here? JavaScript developers has front-enders and backenders. And who is working actually with Node.js in production? Perfect. There's a lot of people. And who has worked since the S5? A lot of hands too. I will show some examples that we work on the new node that we can use a lot, but you can also use this for old versions of Node. I will show actually these examples of Node, but it also works on browser. So let's do it. So this talk is about performance. This talk is about how to improve your application, just making a few changes on your application. I've been working a lot with Node.js performance on my company, so I work with financial companies. So we know that working with money is not that easy, so we must deliver more, doing less, so spending less money. And there's something really fun that we can make using Node, and Node is so much powerful. So first, we just must understand a few questions. So why should we care about application lifecycle? Today, we have Amazon, we have Azure, we have Google. If we need more processing, just schedule a new VM. We have no problem. So we can use any tools. We have auto-scaling. But sometimes we know that it doesn't work as we planned. Sometimes JavaScript doesn't work as we are expecting. So we should care about something. And working with Node, we know that the event loop, like the core of the node, is single thread. As single thread, if something really wrong happens, your application is down. So you should enter your VM, you have to restart your application, and you have to do all of this manually. Otherwise, you can find like this kind of error, like maximum call stack exceeded, or like your disk, you have not enough space to store something. So I will show something that might help you to avoid this kind of problem. And actually, the goal here is small changes would fix a lot of big problems. Like in my company, we have a legacy application, and we are trying to do the same that all people is doing. We have a monolith, and we are trying to break in microservices. And I was like looking in the code and looking for what I could improve. And a lot of changes that I did is just avoiding processing things in memory or caching applications, and actually really small fixes, but we can improve a lot. So this is amazing. But first of all, let's start talking about JavaScript. The JavaScript has a lot of things that is different. People that came from C#, from Java, they have the meaning, they have the knowledge about how to use and how to process. But in JavaScript, we know that sometimes it's hard. So this is a good question. What is the hardest behavior that we have in JavaScript? You in the back, what's the hardest part of JavaScript? Could scream. Types. Types would be. So you, what's your opinion? What is the hardest behavior in JavaScript? I didn't get it? The context. So my opinion is synchronized operations. So I mean, like, my opinion, if you understand how callback works or how the event loop works or how the event handling helps or not in Node, you can do everything. And you just install packages and continue your applications. So how to synchronize? We have a lot of things that we can do. We have a lot of ways to do, and many junior developers are like struggling with JavaScript because they don't know how to start and what they can use. So let's look at this code. So this code actually is a ugly code, but it actually works. So if we run this code, we can see the result. We can see the result is OK. But what is wrong with this code? So what is not wrong with this code? When we go, we have the callback here. We have then and catch here. We have the callback right there. And we have the result. So sometimes this would be hard to manage. Sometimes you are struggling a lot of concepts, and maybe you can use one of them or just avoid using everything in the same code. And you have async await as well here. So if you have then catch, if you have promises, you don't need to use that. So pay attention in what you're doing, and pay attention what your team is trying to do. And maybe you will learn more and more about JavaScript. And sometimes you really want to wait for something, or you really want to, like, your third party is processing in background, but you have to process in the same time. Sometimes we don't need, like, in this case, I have all people, I have all cars, but the cars is not dependent of the people. I can bring all people, and I can bring all cars, and I can return all of them. When I run this code, I have like the result using async await with 6 seconds. I just got to the database, and I wait for the last execution, and then I got the result again. Doing the same code with a small change. I just remove the async await, and now I will run it in parallel. It's not parallel because JavaScript is async. So now the JavaScript doesn't wait for that. So we will have find cars, and we have the find people, and we use promise all. So I will solve all of these results, and I can see this problem. And see how is the result? Now it's half of the time. So we can just change a little bit and need to improve like twice more. So it is so amazing. And effective loops. So this is hard to manage. Like we have map, we have reduce, we have for, we have foreign, we have a lot of things. And this is the problem working with Node. And the people said, no, Node is not for high processing, it's not for using CPU, because they don't know how to process this kind of thing in memory. So let's see code now. And a lot of polemic language. Yeah, polemic topic. Is JavaScript a programming language? Oh, I don't know. I'm not talking. Yeah, I will just show a few concepts. Yeah, I won't fight here. So let's look at this code. So we have map, we have filter, and we have reduce. So this looks like something that works on functional programming. If you go to Haskell and if you go to F#, they can reproduce all of these functions in one single query, one single function. But in JavaScript, it will inspect the whole collection on map. We will get all salary from map. We will inspect the whole collection again in the salary. And if you match this query, we will use reduce, and we will just go away 3 times. So we have 1 million employees. We run like 3 million interactions. So maybe it's not so good. But it's fine. We have like 200 milliseconds. It's not that good. It's not that bad. But imagine if we just change this code for imperative code. Oh, this is so polemic. If you have just change the algorithm. Like here, I have a code that looks like more, I don't know, more uglier than the other. But when we run this code, we have 20 seconds, like 10 times faster than another approach. I'm not talking about avoiding using map. I'm not talking about avoiding use reduce and filter. Just to look if you really, really need to use these functions when you're doing your application. And this will block your application until the operation will return the result. So yeah, be careful. And here we have other concept like who came from C#. Oh, a lot of came from C#, from Java. Oh, from Python. Oh, just one guy. Oh, old school. Here, it was like when I saw first JavaScript, I was like, okay, I can use that and I can see the result. For each operation, I will use await and I will push this result on array. So when I run this code, we can see the result. So I will just using the structuring just to get the ID, and I will find the hero with that ID. When I run this code, I can see the result like 20 seconds to run this application. Maybe we can have other approach. Maybe we have other thing to solve that problem that will be faster. We have the same code. I just remove the await, and I put on promise all, as we did before. But now, if you use promise all for that, we have 10 times faster. So this is amazing. So just changing a little keywords. I know that looks like so obvious, but in production, working with money, we know that sometimes we don't think about that, and it's something that we should learn. And cache as much as possible. Cache sometimes is magic, or would be a problem. Would be like so expensive to maintain, and it's hard. Oh, if you publish these pictures on Twitter later, I will show to my mom, yeah. So cache, first of all, user experience is important. Your developer or the third part or your consumer is your user experience. Is the user affected, the stakeholder. So if you do like an API that will spend 10 seconds to respond, they will hate you. Or otherwise, if you have like a not documented application or API, they will hate you. Using cache, we can improve this more and more. So as we did, like the other talk was talking about meta-programming using cache. This is so amazing for our users. But I think nothing is a bulletproof. So we have to think in a little concepts before starting and before creating something using cache. First of all, how often your data change? You need a real-time application, or your application will just change in a month or once a day. Maybe if you have no precedence or you can see how much it will change, would be good to go to cache or not. And how many requests, how many customers you have? So you have 2 customers, oh, never mind cache, no, that's fine. But you have more, you have to respond more and more, you should think about putting cache in your application. And how much it would cost? So this is a good question, because when I will try to sell this idea to the boss, he will say, okay, this looks like so good, but how much? How much will be from my credit card? So maybe you should put this in the pen and try to see if it's really, really nice for you or not. And try to find where is the bottleneck. In Node, we have some libraries that we can cache variables, we can cache requests, we can cache queries, and we can cache a lot of things, just making small changes, and it will be really, really nice for you. Yeah, cache is amazing. And for who doesn't know or never saw cache before, it's just we have the first customer just coming to our application. Our application will run, we execute, we process everything, and we'll get data from database. But when they return the result, we will get this data processed, we will put in the database, and on the second request or the other requests, they will get from cache. So now they don't need to go to database again. They can go from this cache, that would be other database or other tools. But yeah, it's improved a lot. And if you're in the browser, we have the API that is experimental, but you can use on Service Worker API. But it's just an example. You can use local storage, session storage, and a lot of cool things to make in cache and improve your user experience. And use PM2. Who is using PM2? Oh, it's amazing. Yeah. For who doesn't know PM2, imagine this scenario. We have this application, and for some reason in production, my database is out. My database just doesn't return any data, and I have nothing to return, and I will start blocking the requests. Working with Node, pure Node, we will see the result, and we will have to enter in the VM or via SSH, restart our application to see if the database is working or not. Actually, it's not my problem. It's not my application problem, this problem. It's a database. It's an external party. Using PM2, we can use an API in second time, in background, and we have the same problem here. But here, the PM2 will start to restart your application. He will try to connect once or every second for you. And when you solve that problem, I will just open my database again. My database is running in background. When I go back to my application, I didn't anything, but it's still working now. If I request this application, if I try to see the results of the heroes, it's on. So I can solve, and I can make sure that my application is not a problem. So yeah, maybe you should know where is this exception, or you should know what is happening on your application, but PM2 will help you a lot to solve this kind of problem. And here we have other things on Node, on PM2. You can scale, you can put more copies of your application, and in which will be like a load balancer inside your application. It's good, it's useful. I don't use this so much. I use like on Docker with Kubernetes or other approaches. But if you want to make something like on Raspberry Pi or, I don't know, you have your ideas, you can use that to solve more, to use more. Because Node, the event loop, is single thread. So you can balance this in your CPUs. OK, implement SSL and HTTP2. Have you seen the talk of Anna? The Anna's talk, she was talking about HTTP3. Who doesn't know about HTTP3? Yeah, it was a surprise for me, too. I was like, my God, HTTP3? Who's using, actually, the HTTP2? Oh, there's not so many people, but there's a lot of people using. But 3, I think, is really new. I don't know what's the difference yet. But yeah, using this, you can improve a lot. So first of all, HTTP2 would be 50% faster than your HTTP application. It uses multiplexing, so you can just respond a lot of files, a lot of things, using a single TCP request. So you can get all of this data just in one request. We have header compression. So the browser and your application is dealing with headers, and they are trying to just exchange these headers and sending and go back with this data, and sometimes it's not so good, and you can have something really fast changing this. And we have the server push. So the server push will send the data to your customer or to your consumer without just requesting. So if you want a lot of requests, the server will just push a lot of emails for you, just using events. And it is binary format. For the browser, it's better than just text. So for the browser, it safely work with binary. And I know that is a lot of context. I found out this image on the Google, and I thought, oh, OK, I got it. HTTP2, just all of this, the waiter will deliver once for you. And HTTP1 will have to make a lot of requests to get this information. Actually, using HTTP2, they have a lot of benefits, but I just bring what I think that is most powerful for us in your scenario. And optimize your response. So maybe I will talk about other polemic thing, but I will show some like benefits and drawbacks. But first of all, know what your application needs and what your consumer will need. So I'm talking about consumer because almost of them will be like APIs, or I'm front-end and I'm just consuming API. And for me, it's painful when I want a data and I have to look at the huge JSON file. And for me, it doesn't make sense because I just need the name of hero, and they send all of the data of this hero. And understand your external dependencies and inspect them. So if you have a third part, I have to access an API of third part, and this API will respond for me in 50 seconds, and I will pay for every request. Maybe you can cache, or maybe you can make another approach just to avoid your customer waiting. So, and understand what your application needs. So sometimes your database, you have pool of connections, you have like queries, you have sometimes procedures to work on your database, and sometimes it's hard to find your bottleneck. And create indexes for non-queries. I did this recently working with MongoDB. It was so funny because people said, no, MongoDB is so fast. We reached 3 million documents there. And the query, when I run the query, the MongoDB said, you should use in-memory process to process this query because it's so huge, we have a lot of data. I said, man, 3 million is not so much. Maybe something wrong. So I got there, I analyzed the query that they are doing, and I changed this for indexes on MongoDB, and it was so fast. So I could just serve from like 2 seconds, 3 seconds for a few milliseconds, just putting the cache. I'm talking about MongoDB, but it happened in Postgres and any database. So this is amazing, and you should know about your database or your consumers. And define boundaries. So what is the limits of your applications? So you should just, you want to return in 1 second. OK, explicit that. So you want to maybe say to your customer, oh, if you want this data, you have to make another request. So you can have more endpoints to go to your data. And for defining this, you can avoid a lot of headaches just defining boundaries to your application. In this case, I have a MongoDB, but it's just to exemplify. Here, I have the query, and I have it's similar that we did in memory. I have the salary. I will get all the salaries greater than 0. I will return to my customer only what they need. They need name and salary. So the ID, the password, and the other data doesn't make sense for me. So I will want only this data and make pagination. So making pagination, your consumer will make more requests for you, but you avoid processing things in memory. So you can just respond faster, and they will get data from your application. So this is super nice, and just a few changes that you can make, and this is fine. So now, another polemic things. Oh, who is using GraphQL in production? Oh my God, yeah, this is nice. RESTful APIs, actually, I'm neutral. I'm not talking about one is the best, one of the wrong, or is the bad. But my point is, imagine your GraphQL request. The GraphQL, you can specify your query and your projection, as we did on MongoDB. But here, we have like all of these queries, and it looks like nice for me. But imagine if you have your legacy application, and you want to change to GraphQL just because the projection, or just because the query. My opinion, doesn't make sense. Maybe GraphQL will help you in other questions. But if you have a legacy application and you want to improve your experience, you can make on your actual simple HTTP request. So I have like here the Postman, and I did as the Facebook did before. I just pass on the query string what is the pagination, what is the limit, and the fields. So what's the fields that I want? So you can do the same that GraphQL does using that way in this specific case that will help you in a lot in your legacy application. So just changing how the consumer will request your data, and I'm sure that you respond really, really nice with less. And spec performance issues is boring. It's super boring sometimes. We don't know what is a performance issue. Maybe 5 seconds for me is awesome. I don't know for how many things I'm doing. And sometimes, how do I know if I have a performance issue? In my case, I knew that I hit a problem with my application when my boss was calling me, man, we are making like a campaign to make more transactions, and we are scheduling a lot of new machines, and we are trying to make a lot of new things, but maybe application is not good. So maybe we have to create. In this case, they are like making a strategy for cloud computing to process everything. And I said, man, we are trying to do a CRUD. Like we have a post, so it doesn't make sense to spend so many time. Like in this case, we have 200, we support 200 requests concurrently, and after the change, we have like 2,000, and I changed only the library that makes the problem. Okay, so this is my application. It requires HTTP. It's just, I didn't install anything on Node. I'm just using the HTTP. And in here, I'm creating an array with 1,000 lines, and I'm creating like a random number. If I run this code, it works. So we can see the result here. If I just run, I can see the result. That is enough for me. It's returning the data and looks like good. But imagine our customers' amount will increase. And sometimes it's not. We will show later how it works. First of all, just a checkpoint. Let's talk about the tooling, how we can find performance problems and how we can actually use. We have a lot of tools, but I will show what I've used because it works a lot for me. We have OX. OX is the same company of Anna, Nearfarm. They create this tool to show flame graphs. So this is amazing. You run your application, and when you just Ctrl-C on your application, it will generate an HTML for you, and will show like a graph. Like this function spent 2 seconds on JavaScript stack. This other function is this time. So this is amazing. I will show in practice how it works. But we can see like the line of code that is the bottleneck of our application. So I'm using a lot, and I'm loving because my boss is just, man, you are crazy in performance. No, this tool is helping me a lot. And here we have AutoCannon. It's also Anna's company that they did this. This AutoCannon is a benchmark tool that we can run a lot of concurrent customers. It's the same idea of other load test tool, but I loved it because it's on NPM, it's the whole Node.js, and it's processing data, using CPU, using a lot of things that many people said that Node is not for that. But this application will show a lot of good things. OK, we have our legacy. We have our application. First of all, let's run this application. I have the OX running, and in the other terminal, I will run the AutoCannon. It will run 100 customers simultaneously for 10 seconds by default, but you can put more, you can put query, you can put a lot of things there. And I could solve like 45,000 requests of this application. Oh, and it will generate after a HTML for us. Here on the bottom, we can see the legend. So the pink is the function that is the hardest or is the problematic code. We can see here that we have the array from, that is really a bottleneck. If we click in this HTML button, we can see actually the result. So where's the problem? Oh man, my problem is on JS file, not on for line. And if you click there, you can see the result. So I can have the whole result, and I know where is the problem of my application. And I can just be aware of this piece of code, if it makes sense for me to change or not, or just keep it for this application. They have also the Clinic.js. The Clinic.js is like a huge tooling that you can make a lot of things. You can generate graphs. You can see recommendations of your code, what is the node is doing, or what is the events working in Node, and they can show everything. But in my case, I didn't use this tool. I used like OX and the AutoCannon, because for me it was simpler, and I could like solve something really, really fast. And here is the result. So we can see like a graph. And if you click on the bottom, we have the recommendations. So oh, maybe you are running something in memory that is crazy for Node, and you should alter. And if you click more, they will show more and more recommendations for you. And it's free. So this is really, really nice, and will help a lot in applications. It works for APIs, or it works for routines, or anything. Being Node, you can do anything using these tools. And if you said, oh, I'm root, I just want to make something by myself, you can go to the Node docs, and you have the Performance API. You can measure, you can do anything using the Node Performance APIs. I don't recommend you to analyze each node. I recommend you to use the platforms, because I don't know if you know, Node is actually, Node is a lie. JavaScript is a lie in Node. You're working with JavaScript, but behind the scenes is C++. We just saw, like on the Anna talk, she was writing in JavaScript, but the outcome, the result was in C++. So we will get like events of optimizations of Node, and it's sometimes hard to manage. And it helps me a lot. So using real-time monitoring to analyze our app. Like my company will have a huge screen showing how is the application going and how many time I'm spending for each request. And what I talked to my customers when I was consultancy, observability is much more than logs. They said, no, if I have an exception, I will log this code, and I will send an email or something like that. But you know only when your customer calls you. So our goal here is to know first, and if you have a serious problem, we will call the customer. Oh, customer, I have a problem here. Maybe 1 hour, 2 hours, I will solve, but I will keep in touch. So this is super nice for the customer, and they will feel like you really care for their application. We've used New Relic. So New Relic is amazing for us, but you can use any tool. So New Relic for us will show transaction time, will show what is the most expensive request or the URL. You can configure like alerts on Slack. You can configure a lot of things. But I mean, if you don't want a super powerful tool, or if you don't want like all of this data, I recommend you just pay attention on this kind of metric, like your transaction time, your error rate. So if your application is being a lot of catch and a lot of exceptions, you should see. And you can see like where is your packages. So a lot of problems in performance that I solved was like older packages, like underscore in 4th version. And now when I just updated, the performance just increased again. So it was amazing, and I could solve just changing the package and the version. And use Node.js streams. Oh, this scares a lot of developers. This is I think this is because it's not so good documentation on the website. Maybe there's a lot of myths and a lot of people coming from other languages, and they try to make this for the easiest way. What is the easiest way? We use actually fes.read file. In this case, I'm working with files, but you can work like processing videos and other stuff using streams as well. But when you have fes.read file, what the node does, you will get the whole file and we put in the memory. When you do that, your application, your CPU or your memory just increase. When you are processing a lot of requests, it's hard to node maintain. Using readable streams or actually using streams, you can process all data like incrementally. You can gradually update or can gradually make some decisions for your application. In this case, I have the red string. I can show, oh, how many bytes I will get from this code. But here I'm working with events. I'm working with on data event, and I can see the result. And when I have the end, I will console the log of the result. But here is amazing. Here is experimental. It's just new. It's not in production yet on Node, but it's so nice to use. Now we have four await. So we have a readable stream. When I have the event on, I will get the chunk. That is the piece of the file, the piece of the event, and I will process. So I can process much more now. I can process gigabytes or terabytes using Node, just using streams. So now you can use a lot, and you can really process things using streams. Streams, we have a lot of concepts and a lot of other good examples that you can use. But I think this is something that we see in production. It's something that we use a lot, and I think that would be good for you to change from FES read file to streams. And here, to show that Node is powerful, I'm reading the Dev Random. It's an infinite file on Linux and Mac, and we can read an infinite file on Node. So in this case, I'm reading that file. But actually, I'm not putting the file in memory. I just request, and I will request the first chunk of data, and I will process it using the for off. So the for off is a little bit different than for in. So we will get actually the object that we receive, and I will show the chunk data, and I will process. I put this sigint. This already is on GitHub. If you want to try this, it's just when you run, when you Control-C, you see the result at the end. So this is just to show, because otherwise your application never stops, because it's an infinite file on Linux. OK, so you are talking. Let's see if it works. If I run this code, we can see this easy code. So I just create a file. And when I Control-C, I see here 9 megabytes that I run from Dev Random. So you can use for a lot of things. But this is so powerful for us. And learn about Node.js native modules. So native modules is a little bit complex than we are accustomed. We have to maybe learn a little bit C++. We have to learn maybe how the API works behind the scenes. But it works so well. And this is my words. What Node can do, it delegates to someone else. So we can process Node in memory. OK, we can use a library that will translate JavaScript to Lua. We'll process on Redis. We'll have the result, and we can deliver everything. So yeah, with Node, you can use a lot of things, and you can make this exchange with other languages. And you have the V8 API. So the V8 API, we can use a lot of things right there. You can change the event loop. You can change how your machine is working. But it's not safe for you to do it by yourself and put in production without a little bit known about what the V8 does. But I will show how to create first. So imagine that we have here a C++ library. So I'm hacker now. C++, we have the NAPI. NAPI is just the API to talk with Node, to make this interaction is the wrappers in your applications. And I have like the function that is multiply. I will pass the parameters, and I will just expose this code. I will expose this code, and I have a C++ code. So my C++ is there. I will just compile this code. It will generate a file. And when I go to my JavaScript application, I will require this file. When I require this file, I can call multiply as well. Looks like a JavaScript function. Looks like something that I can really manage. Imagine that you are trying to make something to change your handle of your PC. You can do in C++, and you can talk with Node, so if you want. So it's super powerful, and a lot of things such as decryption, encryption, is doing with C++. This is sometimes scares a lot of people when you go to a package on Node, and you go to the Node modules, and we click to see the implementation. It's just C++. You said, oh my God, I'm lost now. But now you can use all of these functions that will translate the C++ to, actually it's not translation because your C++ is what they will run in the code actually. And when we run, we can see the results. So exactly the same that we had on JavaScript function. It's so popular. OK, so before I conclude the code, so let's go to the questions, because I have a lot of 404 faces now. So anyone questions? Oh, yeah. Oh. But performance is not boring. It's amazing. If you want, like, your boss will look at you different, or your customer will see that's super, super powerful.
Thank you for a great speech. Looks great. Looks very emotional. It's fine for us. But I have a question.
Yeah.
How you can comment this site of Donald Knuth? Premature optimization is the root of all evil in programming.
Talk again, sorry.
Premature optimization is the root of all evil in the programming.
Whoa, yeah. Progressive programming is the evil.
Premature optimization.
Okay.
Premature optimization is the root of the evil.
Yeah. This is a good point. Like, when you are trying, let's see if you understand. Yeah. This is something that when you are making an application, when you go to performance and you have no measure. So you have to create a measure, and sometimes would be an evil because you are like, man, I need to perform more, I need to execute more. So maybe what we are trying to make in our company, we have what is the basic that we have to deliver to the customer. Like for us, it's 300 milliseconds per request. And then after that, we will see how it works and if they need it or not to use more memory. I respond to your question?
Okay.
Awesome.
So you agree that all these tricks is not okay to implement at the start and from scratch that you only develop in development stage. It should be after some user feedback, right?
It depends. It depends. Like with working with loops, maybe you can change. You keep in mind how your application doing. But in my experience, all of the performance problems looks at me after production. So, is it production? Something is a chaos. But it's good to keep in mind, like, start your application with like a monitoring, using New Relic, or using other applications. And caching, maybe caching would be later too, because it's something that costs a little bit. But yeah, I think in code should be good to start with.
Okay, thank you.
Yeah.
And another question. you show 3 approaches in development. It's like a reactive approach, reactive, yeah, and other things. Do you think it's okay to mix all these approaches in one code base?
Yeah, I think it's not a problem if you have like organization. Like using map, filter, and reduce, sometimes we use a lot in our application. It's not so problem. But sometimes, like when we need deeply performance and when we have the bottleneck, I change to imperative code. So it depends. Depends what you are processing. Like if you have pagination, maybe you don't have problem with map reduce. Maybe, yeah. It depends on your application.
Okay, thank you.
Oh yeah. More questions? Oh, questions.
Thank you for the talk. It was really emotional and exciting to listen. Yeah, driving. I have I think it's not fair when you compare functional and imperative style, give the benchmark, and didn't give the way how to fix functional style. Why didn't you tell us how to fix it?
Ooh. It depends. It depends of the case. Like in this case, I'm just showing. Oh, you want to use this, just be aware what your application is doing. Like here I have 3 or 4 more. We have actually a library that can convert your data. Oh, don't go. Let's take a picture later. I have to show to my mom, yeah. And sometimes, yeah, I have to show my mom. Sometimes you have a library, it's Ramda.
For example.
Yeah, Ramda, they said that is really nice to make that, but in my opinion, for that example, would be imperative way would better, yeah. It depends on the case, yeah.
But the performance would be the same.
It depends, because in that case, I have like I have a collection and a million users. So I running 3 times, I have to process 3 times more. I will spend more CPU and memory, and maybe I will block the event loop. Using the imperative way, I just run a million. So it's just once and just fixing with using algorithms. So in that case, it would be fast.
But with Ramda and Lodash, you would also run only 1 million cycles. You won't run 3 millions, only 1.
No. In this case, will be 3 million because for each request, the node will inspect the whole collection.
No. In Lodash, it will optimize. In Ramda, you can make.
Oh, no. Using Ramda, yeah. But the native function will run, yeah.
But you can have both.
Yeah, sure. No, this is something that I'm talking. It's not the bulletproof. It's what is better for you, but just be aware what you can do or not on your application.
Yeah, thank you.
Oh, you're welcome. More questions. Oh, questions.
Any more?
Okay. So let's go to the conclusions. So before we finish that. So the conclusions here, performance is not application problem. Performance is human problem, is human errors. A lot of problems that we saw in production is not because Node couldn't solve, it's not because Python couldn't solve, or Java couldn't solve. It's something that developers are struggling with, and sometimes we should just see what your application is doing. So try to make your developers good and try to teach how JavaScript works, that I'm sure that all of performance problems, not all, but almost of them could solve using this approach. And be aware what your application is doing. So your application is responsible to make a CRUD. Why are you running something background to process like a routine in the same time of your application? Sometimes it's not so good. And keep JavaScript packages up to date. In my case, I just update the underscore package, and my performance was so much better. So try to see where is the bottleneck of your application, or just update your packages and try to see what would be happen on your app. And learn JavaScript. We are here to learn JavaScript. So JavaScript is an amazing language. Now it's an amazing language. It is improving every day. And try to understand what is the life cycle and how JavaScript works in each platform. And gotta go fast. So you can use all of these tips in your production apps or your legacy apps, and I'm sure that your customer will be happier with your application, and actually you can spend more money in beers. So you can use your money for something really nice. So here is my website. All of these talks, all of this content that I'm doing is already there. If you want to make something, if you want to get the links, is already there. I will show here too if the, oh, thank you so much. Oh. Now is the links. Yeah, if you want to take a picture of these links. So all of the examples that I used is already on GitHub. So if you want to get, the presentation is already there. Follow me on Twitter. I always publishing content, just sharing knowledge. I'm not the best. I'm not a really one. You can follow there and see memes and GIFs. And if you want to see the reference, there's a lot of reference that you can see right here. You can use in your production apps. And all of this talk is actually something research and something that I've worked. So I hope you enjoy it. Thank you so much.